All right, welcome back to AI for 2021 Finance Summit, presented by Data. I hope you're having an awesome time so far. I'm excited to introduce our next panel, The State of AI in Banking. Please join me in welcoming our panelists to the virtual stage.
Thanks so much for the introduction, Patrika. We're very excited to be here and think it's pretty fair to say that artificial intelligence and machine learning have moved from the realm of academic research to the power of commercialization. And often when we think about AI, we think about large consumer internet companies, the likes of Google and Facebook, who have very extensive machine learning science research labs. But today we're going to talk about applications in another industry, namely that of financial services and banking. So I'd love to start off with an introduction from the fellow panelist speakers today. Alex, why don't you start us off?
Hey, Kathryn, thanks so much for the great introduction and everyone for being here for the conversation today. So I'm Alex. I'm one of the co-founders and CEO of Snorkel AI. We're a company that is building a platform called Snorkel Flow, serving customers in the financial space along with others. And I'm also on the faculty of computer science at the University of Washington. Super excited to talk about this today.
Ashit, why don't you go next?
Thanks, Kathryn. I'm happy to be here with my co-panelists. So I'm Ashit Talukder. I lead the AI machine learning initiatives at Moody's Analytics. Brief introduction to myself. I worked in R&D and AI for over 20 years. I have a PhD from CMU in the 90s when literally AI was still in research labs. And I started my career at JPL NASA, so I'm the only rocket scientist here at Moody's Analytics. Probably in the panel here too. So I did my research at JPL NASA for over 12 years. And then as AI kind of evolved into more enterprise type domains, I went to NIST where I started the data science program. And then I've been at Moody's for about 4 years now. I lead the AI Center of Excellence here. So over time, we have actually built up a large team of AI experts, and we kind of lead both the strategy functions and then the product initiatives here. So I look forward to the discussions.
Wonderful. Prashant.
Hi, thanks, Kathryn. I'm very happy to be here. Thanks for providing the opportunity. My name is Prashant Dhingra. I lead machine learning practice at JPMorgan Chase. I'm a managing director for machine learning. Prior to JPMorgan Chase, I worked at Google and at Microsoft. So I was heading machine learning for IoT domain at Google, and I also worked at Bing SQL Server and Azure machine learning product at Microsoft. I think I moved to AI at right time. I used to be a software engineer, and then in 2008, I was head of BI COE at Microsoft. And the stock market went down in BI and the budget was crunching. So that time I took a position in machine learning. I moved to Bing from BI. And since 2008, I've been working in machine learning, and it has been a very interesting journey. I think AI will continue to grow, and I have found it very rewarding. And I believe people who will be participating and using more and more AI, it will make them wise in a daily life, and whether they are in AI role or not. So I'm very happy to be here, and I'm looking forward to share our experience.
Thank you, Prashant. I'm Kathryn. I currently head up a group called Borealis AI, which is the machine learning research lab for the Royal Bank of Canada. I've been working in the machine learning space for the past 6 years. I started my career in this field at a startup called Fast Forward Labs, which was subsequently acquired by Cloudera. And in that capacity, had worked with over 50 Fortune 500 companies, advising them on their enterprise machine learning strategy. I bring a slightly unorthodox background. I started off my career in the private industry working for a legal software company and gained expertise in risk management and professional ethics in law firms. I had a stint as a professor, an associate professor of law at the University of Calgary, teaching how ethical paradigms were being impacted by new technologies. And so bring that ethics and governance lens to my work in machine learning, which is quite relevant in the field of banking as we think about compliance with regulation and all of the sort of beyond regulation ethical considerations we have to take into account as product developers and machine learning practitioners. So I think it's fair to say as we listen to these introductions that we have a nice diverse set of viewpoints on the panel. I think there's both Prashant and I come from, we're working for financial services institutions themselves. So we have that sort of inside inside view on where banks stand. I think with the perspective from Moody's, we have the layer of credit analysis in the larger industry, and then obviously with Snorkel, there's the not quite fintech, but I think sort of a machine learning startup perspective on the outside in serving the bank. So I think there's a broad set of perspectives that should lead to a rich discussion.
I can be more blunt. I mean, we sell software to banks, so there's my bias. Although a lot of our theory that we worked on back at Stanford, where the project started, is specifically about how you can get very useful signal out of even biased or noisy signals. So there's my perspective on the table, but also through Stanford and University of Washington, talked just from the kind of broader ML systems and ML research perspective with hundreds of Fortune 50 companies, including many of the major banks. And so I'm excited to kind of chat both with my Snorkel hat on about without detail some of the value that we're helping to support in real deployments, but also just about some of the challenges and honestly some of the unsolved problems that I've heard echoed in just conversations in the broader space. So but anyway, Kathryn, super excited to proceed with the discussion.
All right, wonderful. Why don't we start up with the first question? So I think pretty broad. Probably some folks in the audience who are listening who are asking themselves, banks and AI and banks, like how tight is this marriage, or is this a breakup waiting to happen? Prashant, why don't you start us off?
So organizing data and understanding data is a key competency any enterprise needs to have, whether it is a bank or health or any other industry. And AI helps us in organizing data. So even if the data, big data technology has come and we are able to capture more data, we are able to understand more data, the world is changing even faster. The rate of acceleration has also increased. So it has become more and more important to understand the data. And to understand data, AI can be utilized in multiple ways. Like many times we only talk about prediction, but machine learning is useful to understand the data, reason the data, and even design what kind of a product should be built, etc. So every company needs to become a tech company and a data company. And the reason finance companies are even better placed, in my view, finance companies can generate ROI from machine learning quicker compared to manufacturing or health domain. Because if you are building an aeroplane, or if you're building you have a large manufacturing plant, it takes like 3 or 5 years, and in an aircraft industry, even more to get an ROI. But in a finance, if you build an AI, you are likely to get results from few months to in a year's time. And finance companies has a good motivation, because finance, finance is important for the society, and it is data driven, so finance is very well placed to utilize the data, make the quants, or make the whole enterprise smarter and wiser. So I think banks will be utilizing AI and machine learning techniques across all the departments.
So I'd like to add to that. Addressing the question that you put up there, I think the correct answer is somewhere in between. It's AI and banks are not a perfect match, but neither is it headed for a breakup. I'd say it's a match with imperfections that need some long-term planning, strategic approaches, and some TLC to succeed, right? Putting it in the context of a marriage. I actually see if you look forward a few years, I see AI and technology transforming banks. And it's actually going to be accelerated by COVID in the past year. And we're going to see that hand in hand with changes in regulations, which actually limit the adoption of AI right now. And I'm sure we'll talk about it a little bit more. And also the emergence of fintechs, I think, is going to drive the legacy banks to kind of force to change faster than they normally would. So there'll be some bumps along the road in terms of AI adoption in the banking sector and in finance, especially for the legacy banks. But I think many will catch up. Now, I'd like to point out, though, that the problems that AI will face in finance is not unique only to finance. If you look at healthcare, for example, it faces a similar challenge. Look at IBM Watson, the healthcare unit. IBM actually spent billions of dollars in the last 5 years doing acquisition and tech development just for healthcare and AI in healthcare. But essentially what happened was it was not being profitable anymore. So the recent news is that they're planning to sell the unit off and look at more profitable initiatives. And some of the challenges that they faced, including Google Health, is in the regulatory domain, which is data privacy and data regulations impose a lot of hurdles. And that's very similar to what the finance sector faces. So I think it's not unique, but we are going to overcome it in the next few years, I would say.
I think that
I
can certainly emphasize that. I'll take it, Alex, and pass it over to you. Whereby it's almost like there's been the use of statistical models in banking for quite a long time. So, credit adjudication, various processes to try to assess the risk of offering a financial product to either a citizen consumer or a business have used data in some sort of modeling technique. So there's one aspect which is, it goes to this sort of perennial question: what qualifies as advanced analytics and what qualifies as machine learning? But I think there is an opportunity to move from handcrafted features to learning representations and potentially adding in new type of modeling techniques to improve the performance of those traditional models. There's certain types of AI where there's a question of how much value it'll add to financial services, and here I'm thinking about image processing and computer vision applications. I've seen some use of processing satellite data to try to either evaluate a home price or in alternative data used in the stock and trading markets to count cars in Walmart parking lots as a proxy indicator for potential success. That's been going on for the last 5 or 6 years. But when it comes to things like an analysis of video data, should we be building that internally at the banks ourselves? My team could work on that, but we'll likely outsource that to the likes of NVIDIA, or Zoom, and have their machine learning teams take care of that. So there's tons of opportunities, but there's also some potential problem spaces where it's best left to external teams as opposed to teams inside the banks. Alex, you were going to say?
Yeah, no, I don't think I think those are all great points. I'm not going to say anything too controversial to add on to that. I think some of our current customers would be angry if I, after having shared excitement about results, in banking on our platform, then said I think it's a terrible partnership and marriage between AI and banking. But not to be too pedantic, I think at the broadest level, AI in the traditional sense just refers to automation of. It's a very broad and classical umbrella term, right? So it just means automation of processes, and I think given the amount of processes that go into such a complex and important system like banking, and I'll focus, I guess, on banking given the prompt rather than finance in general, because I think ML, AI are used in very different ways if you're thinking about a quant trading firm versus a bank proper. I know the line's blur, but so I think AI in general, can we achieve some automation? Of course, automation that both assists analysts as well as replaces some functions, or rather, whether it's decision making or structuring of data, like you said, Prashant, and like a lot of our work is in. I think broadly there, the answer is just kind of almost trivial to say yes, of course. With such a complex system with such flows of data and importance, the answer kind of trivially is yes. Then you kind of get the next concentric circle of machine learning, where it used to be called statistics, and now it's machine learning, or it used to be a logistic regressor, and now it's a single layer deep neural network. If you're if you like that joke, not really a joke, I guess that's how things are phrased these days. But machine learning has been used in that there have been statistical models being used in banking and finance for decades, right, for centuries, depending how you define it. So there, I think it's undeniable there's value. And then you get to the question of, what a lot of people refer to and are excited by, and a lot of us are working with, which is kind of modern, ML methods that are getting people excited. Often you're talking about, deep or representation learning methods like you referred to, Kathryn, where you're not only learning a machine learning model, but you're kind of learning all the features and a lot of the kind of architecture of the model just from scratch with data. You can handle all these more complex unstructured data types like text, PDF, websites, image, video, time series, beyond. And there, I think obviously we work in that space. We've seen some of the places where it provides value, working with, obviously customers in many verticals, government, medical, insurance, retail, but also, with some, major US banks currently as customers. But, I think it has, there's a great opportunity there, but there are, obviously significant deficiencies with how it's being kind of the standard way of using these modern techniques today. When you come to, banking or really any other industry where you have, considerations around things like privacy, auditability, just consequences. You're not predicting cat versus dog. You're making very momentous or important decisions, and you need to be able to audit and interpret and react. And also where you have a lot of data privacy, you have a lot of expertise that needs to go into preparation. And I'm assuming we'll talk about some of those interesting challenges and opportunities, as the panel goes on. But I can give the quick perspective just of where I'm coming from. Most of our research originally at the Stanford AI Lab for many years with an open source project called Snorkel, and now in a company called Snorkel. We're very creative namers, where we're building a platform called Snorkel Flow that's serving many Fortune 50 customers, including in banking, also in the government side. So many of these areas where you have very private data, lots of expertise needed, very important decisions around this data. To give a sense of applications, often our platform is used in the banking world to do things like help make decisions or extract information from complex documents, PDFs, news data, news feeds, network data even. It's a pretty general platform, but the kind of core motivation for us over the years has been about the what's called training data that's needed to teach these machine learning models. So, I'll throw that out there, and maybe we'll circle back to when we talk about some of the challenges. This is one that we have focused on and anchored around for years now, which is, all these methods seem almost too good to be true. And you can look at the results that, we and many others in the space have published, and they honestly sometimes are, but there's always a catch, no free lunch. And the catch is that they are extraordinarily data hungry, and not just, any kind of data from the, data is the new oil era, where it's just collect all the data, from, all the websites, all the things, but data that's been carefully, labeled, curated according to specific business objectives, specific, pipelines. And this is what we call training data. So, you want to teach a machine learning approach and modern AI approach to, classify legal contracts in a bank. You need to have some legal associates label thousands or hundreds of thousands of, those documents first, according to the spec. And so this is really difficult when, you're not labeling cats and dogs, which you can do cheaply, or stop signs, but you're labeling, highly complex, private, and data types that, and the way you're labeling them shifts constantly in regard to, objectives. And so I think there are many challenges, but how you manage that data that fuels all of this AI progress is one that we focused on, that I think is both, highlights the opportunity. We're working on programmatic ways of handling this that have been very, had some, nice successes, but also just the challenges that, this is the foundation that modern AI rests on, is tons and tons of nicely curated data. And, you think, oh, banks have lots of data, but, is it nicely labeled, or is it easy to get it labeled or set up in the right way for modern AI? The answer is mostly, no. And so, anyway, I went way too long, but I think I'm dipping into not just the excitement part, but the challenges part. But I think the answer is, I think there's significant challenges with just taking all the exciting AI progress, and especially deep learning progress we see, and just plopping it into the banking world, really just like there is with government, with insurance, with medical, with any kind of serious setting, but also tons of opportunity. Anyway, I waxed too poetic, so I'm going to cut myself off.
I think Alex already transitioned us to the next question, which is, the various challenges that banks face. So we've touched a little bit upon regulation, but I think we can go deeper in that. And then Alex, talked a lot about the fact that I think it's right. We went through the sort of data is the new oil era. And I think a lot of the financial services institutions, and this goes across industries, they've absorbed that, that they need to have a lot of data, but they haven't always thought about it with an eye towards labeled training data sets to support supervised learning applications. So that's definitely one area. Prashant, how about some others?
So regarding the challenges, not only bank has this challenge, but other enterprise also have this challenge that and bank are impacted more. So if you think about machine learning gives you abstract information from data. And if you look into even complex neural network, each layer abstract the data, pass it to higher level layer up to a point where your task is done. So it's all about abstraction. Now, historically, banks have used statistics, so they follow equations. And if something can't be written in the form of equation, it requires a significant change that now the life is based on approximation and abstraction, not on equation. And it impacts all industry, but I think it impacts banks more. Having said that, I think I have seen a significant progress in bank. Once we explain the concept, banks are more and more willing to follow this path. And many times we hear this concern about regulation. And I personally think that regulation also impact Google and Facebook, and probably they are scrutinized more. So if they have overcome that challenge, banks can also overcome that challenge with the right education and with the right leadership in place. The one area where I see, which I see a big challenge in innovation in ML is most of the time we hire PhD or graduates who bring a lot of expertise and skill, but we require also experienced ML leaders who should know what is a good experiment versus what is a bad failure. Because companies keep doing an experiment and then they say it failed. So on one side, we need to encourage good experimentation, but on the other side, we can't just keep on failing and saying that these were experiment. So there needs to be a clear philosophy. What is a good experimentation versus what is a bad failure? And once we have that philosophy, and if we then move the needles toward good experimentation, it turbo boosts the innovation. So I think that is a key area we want to focus on. And by focusing on good experiment, one can innovate faster. And this goes back further to the data. Like earlier, we talked about data challenge. So that one requires label data, but ultimately the goal is how well we can monetize our data, what information we can get from it, how we can make our quant and like workforce more wiser so that they can make better decision. So with the right experimentation, we can get the meaning from a data. We can also explore what kind of a new product or what kind of a new philosophies needs to be brought in. And that's why banks can even beat fintech, because they have large amount of data, and with the right amount of exploration, they have a competitive advantage. So in my view, the biggest challenge is how we enable the good experimentation.
Yeah, I just want to. Oh, sorry, I should go on.
Yeah, I tend to agree with that, and that's where I think the legacy institutions have some challenges, because they have a lot of data, but many of it is siloed, it's fragmented in legacy systems, and that poses for the legacy, the incumbent banks, a challenge for them to leverage the data and build AI models that then add analytics and value on top of the data. So that's one, I guess, area where banks face a challenge, and the incumbents don't have the legacy systems to deal with. I'm sorry, the newcomers, the fintechs, don't have the sort of the legacy system to deal with, so they can actually build the IT, the technology superhighway from scratch. That makes it easier. Talking about regulation, I know we touched upon that. Prashant talked a little bit about it. We see some recent emphasis and research progress on explainable AI models. So AI is typically black box, as we refer to, compared to the credit decisioning models in the past, which have been statistical based. But I think with some recent progress in explainable AI models, we're going to see some better adoption of AI across the board in credit decisioning, KYC, and so on. And the other thing that banks, I think the incumbent banks face, the challenge that they face, is that on one hand, they must manage the scale, the security standards of a large enterprise, right? Because they have these legacy systems to deal with. And on the other hand, they have to achieve the speed and the agility, flexibility of fintechs, which can move much, much faster. And I think I've seen a lot of motion around that, where now the legacy banks have set up innovation units. I mean, we are part of a innovation unit from which the AI Center of Excellence operates. And that allows us to literally go the speed of a startup while leveraging the legacy data that Moody's has, that the financial institutions have, to build better decisioning capability using the legacy data, the tens of, 50 years of data that we have. The other challenge that I think the legacy banks have is also talent. So there's a lot of expertise in statistical techniques using, traditional languages like R. But now with the prevalence of AI and ML, you almost have to upskill the existing talent base to avoid rocking the boat too much. And that's a real challenge that banks face, but they're going through upskilling of the existing talent. And then, my AI unit, we make sure that we basically hire people with deep AI expertise, and then we follow the hub and spoke model, where we provide the AI expertise, and then the business units actually provide the business needs, the business drivers. And that's a very nice way to actually build up these AI initiatives quickly over time.
It's interesting because we have the same model. So the hub and spoke, where, the team that I lead is the machine learning expertise, and then we partner up with the different business lines to deliver applications. But I do think one of the challenges is finding requisite domain knowledge to both inform the structure of the model, going back to Alex's point, and really understand the business problem. We talked a little bit about banking versus finance, but I think this becomes particularly acute in collaboration with our capital markets colleagues, because the space, if we think in bank, in the consumer retail banking world, we'll build out personalization applications into the mobile application, and it takes some time to understand the space, but there's sort of an intuition that the teams have, even if they're not, deep domain experts in financial services. But once we get into derivatives pricing, where, as we've discussed, there's today the legacy functions are quite complex and take quite a long time to compute and execute. And so there's an opportunity to use functional approximations using, the modern toolkits to trade a slight bit of accuracy in favor of computing the price or risk of a financial product in seconds as opposed to days. So there's a lot of benefit, and my team will bring in the skill set, but it takes us a couple of months to read the textbooks on derivatives and really understand the space, as well as the legacy infrastructure environment. And I think the second part where it can be tricky is just getting a machine learning system into production. And building the right integrations. There's always decisions of the short term versus the long term. Which platform are we going to upgrade across the enterprise? Where are we happy with some hacky solution where we'll throw away the code in a couple of years? So I think these are standard. This is outside of the domain of AI. It's sort of any innovation in a legacy environment, but we certainly see that. The other one that I wanted to touch upon, going back to Prashant's point on experimentation, is, and again, this is across, I think, traditional industries, the comfort with uncertainty, both in the early phase of the product development process, where we're not sure if the model is going to converge. We're not sure if we have the data. So I think about it as fitting the square peg of experimentation into the round hole of KPIs and business results, where there'll be a little friction, and having the business partners that we collaborate with be comfortable with the fact that this might just not work. It's not like we're not managing risk like Agile, where we're cutting down our sprints to 2 weeks with the knowledge that we want to get feedback on features before we commit to a long-term dev. It's like, it could take 2 weeks and it could take a year, we just don't know before we start. And then the second cultural shift, I think, is comfort with a probabilistic output. Prashant, you talked about these layers of abstraction, but I think there's reticence, depends on the problem space, but particular with a client-facing application, reticence to predict cash flow incorrectly, and lose customers' trust, not only around data privacy, right? So lots of concerns around ensuring that the trust is there, and customers don't have a sense that we're using their data in an untoward manner, but also there's a broader shift to be done to educate the general populace in processing probabilistic outputs. And understanding confidence ranges, et cetera. And I find that actually a fantastic design question for AI product development at scale, but it can slow things down because sometimes the bank is not quite comfortable with putting forth a feature that has 50% accuracy or something. I want to move on in the interest of time. Our next question, Patrika, I think it's around concrete use cases. So let's do this one a little quickly as we move through, but how about for each of us sharing one particular opportunity or use case around AI?
Okay. First of all, in general, the reason I changed job from Google to JPMorgan, I saw that there is a regime shift happening, that earlier product company used to build a product using code like Microsoft, then Google built product using consumer data. So there is a lot of opportunity to build enterprise solutions which Google or Amazon can't build. Like even if they are building various AI solution, but they can't build it for finance domain. So I think there is a lot of opportunity in finance and other domains where, depending upon data, solution needs to be built. So now going specifically, so you will see like there are various problems which are considered unsolvable problem. For example, whether if you try to build something for explainability for the whole world, or AutoML for the whole world, or even reinforcement learner for the whole world, these are unsolvable problem. But the opportunities we have is like when we work in a bank, if we constrain a problem to a domain, we can convert these unsolvable problem into a solvable problem. So that's the personal motivation I saw that regime shift, and I changed job, and that's how like we hired other member, and we see that once we have that data related to bank, so whether it is a NLP data, which is it may be earning calls, or it may be how trading happens, one can build lot of things which rest of the world or rest of the product companies can't build it for us. So that is the opportunity I see it broadly. So I will not be able to share explicit detail about the use cases, but I see a lot of success by constraining a problem to a domain, finance domain, and then solving it.
Yeah, I can jump in and broadly say I obviously can't share customer details, but at a broad level, there's a huge opportunity with modern techniques. Even though I was talking about challenges with respect to them, which obviously is why our what we've been doing. Huge opportunities with respect to especially unstructured data. So think about things like text is a canonical type of unstructured data. Something that we often call semi or richly structured data. So HTML, PDFs, things attached to emails. But of course, extending into network, image, video, et cetera. But especially I'd say around just large, complex, unstructured documents, PDFs, et cetera, being able to classify, route them, extract information from them, essentially turn unstructured data into structured data. Imagine taking a 300-page document, turning it into an Excel spreadsheet with columns that are specified according to what the business objectives are. And so that's what where there's been, in some senses, the biggest delta of progress if you have enough training data. And on that front, I'll mention just briefly that data is still oil for ML. It just needs to be refined. That's the kind of cheesy way to say it, but very directly true from our perspective, right? So banks still have an incredible amount of this data and the subject matter expertise. Maybe we'll talk about that later, but Kathryn, to your point, the domain expertise is absolutely critical here. You essentially need to fuse the data with, in supervised learning, like we work in, how to label it, but also more broadly, just that domain expertise. Banks have tons of that stuff, both, and so there's a tremendous opportunity to pair, the data, the subject matter expertise with modern machine learning model architectures that have seen, massive advances in the last, 5-10 years around specifically unstructured data to see some exciting advances there. So tons of places where good old-fashioned ML, should still be the way the land, and has already always had tons of value. Statistical models, which technically is still ML, But I think this is where I see the biggest delta, and certainly where we're operating and seeing lots of value added.
Yeah, exactly. And I'll try to be specific in how we tactically and strategically address AI for Moody's Analytics and the clients that we serve. So, I mean, across the board, as all of us said, we see AI helping in the back office, the middle office, and the front office for both within Moody's and for our clients, right? So in the back office, being specific, we see AI replacing sort of RPA-based solutions for better automation, and specifically to NLP and unstructured data. That's where we see the biggest bang for the buck. A lot of analysts spend manual effort in reading, understanding contents of news articles, financial documents, and we have built these AI solutions that can actually automate this to a large degree in the back office. So we actually got a quick spread solution out. It's an automated spreading tool that helps automate the financial spreading process. We've won about 4 financial awards for it in the AI financial services domain. In the middle office, we see use of AI in better decisioning for credit, KYC compliance. We've got out, again, being specific, an adverse media monitoring tool that helps doing adverse media checks for compliance, ESG and other applications in a matter of minutes rather than days. And then in the front office, we see kind of using AI to personalize the user experience for our clients. And really, that's really what clients expect right now. Whether it's a B2B client or a consumer client that you're serving, that hyper-personalization is very critical, and that's where AI can help do this at scale. So the way we actually do this strategically is we've built what we call an ML fabric. It's a machine learning fabric. And we have all our machine learning AI components that are custom trained on Moody's data sitting as microservices. So we call them AI Lego blocks. And then we use the same Lego blocks to build multiple AI solutions across the board. Maybe NLP solutions will use the same set of Lego blocks, but tied together in a different manner. So by doing that, we are not having to retrain new models every time for different products, for different processes. And that's actually helped us speed up our time to market for AI products very quickly compared to what we were able to do before.
I think that's great. I'll talk about one that we talked a lot about, supervised learning applications. So having that labeled data and cross-checking the predictions that you have against the ground truth to improve performance over time. But there's another domain called reinforcement learning, which in short is applying a technique to a sequential decision task to try to optimize or minimize something by taking the right actions over time to achieve that goal. And so we actually found this is going back to banking versus financial services, but we found a great use case of reinforcement learning in our financial markets around executing a trade, in particular to achieve a trading strategy called VWAP, the volume weighted average price, which is a very common strategy in the markets. And for reinforcement learning, quite nice to use because it's a clear objective function to aim for. And so we found, at the beginning of the day, client will come in and they might have a bulk order of stocks they want to sell or buy. And if they were to do that all at once, it would potentially change the market, right? It would fluctuate the price too much. So the question is just how do we sequence the trades over the course of the day so as to stay as close as possible to that VWAP curve and not, shift the waves in the market too much. And found this was actually a nice implementation of reinforcement learning. So I think what I like about it goes back to what Prashant said about not sort of boiling the ocean and having like general purpose ML. But we started with a really specific problem, got our first version of the product out for the particular reinforcement learning VWAP trade execution. But then once we had that, we could build additional trading strategies on top of that. So moving to an arrival price trading strategy, liquidity seeking is another term. These are terms of art that have to do with different institutional client trading preferences. But it's sort of that base, right, that we could really build upon. And it was interesting as we worked on it because, it's not just a science, it's not a plug and play application. There was a lot of work that went into handcrafting the input features, having the backbone recurrent neural network sort of time series data model that could capture market information. So I think it's really exciting space, but again, started off with solving a really precise problem and scoping it down, having it very narrow before expanding and building on top. Pratika, why don't we go to the next question? All right, so this dovetails with regulation, but as mentioned, I think traditional regulation has focused a lot on consumer protection. I'm coming from Canada, so the regulatory paradigm is a little bit different than that governing consumer rights in the United States. But definitely the case that the compliance departments in financial services companies at large have not historically been thinking about questions like bias or explainability of models. And it goes back to the fact that, you know, we've been using statistical models for a long time, but traditionally we were able to name, you know, the list of our input features and likely the associated weights with those features, as opposed to potentially having sort of a black box where we're not sure exactly how that input leads to the output. And so this is a question we think a lot about at Borealis. And actually it's been an AI opportunity for us where we've got a team working on a automated model governance and verification platform. So it kind of falls into the broad range of ML ops, machine learning operations tools. But we're seeing it as a sort of, an opportunity to help contribute to the dialogue around fairness and bias and take it from the domain of principles, right? Sort of do no evil, you know, sorry, no jabs to Google. Treat people fairly, right? This becomes quite dicey because, and I think the interesting challenges that we face is that we think when we use these terms qualitatively that we know what they mean and we agree upon their definition, but when forced to define that formally in a modeling context, suddenly we might realize that in the example of fairness, there's 21 different technical representations of this apparently uni-representational, univocal term. So I think it's an interesting time, you know, in the machine learning community as we're seeing this need to formalize these definitions lead to interdisciplinary discussions with the legal community, you know, the sociology community, and intertwining that with technical communities to come up with the right solution. Ashit, you'd mentioned a little bit on sort of developments in explainable AI and how that might lead to evolution and regulation in evolving the dialogue. My take in Canada is there's a new bill that recently was released. It's called Bill C11. It has provisions relating to privacy as well as the almost like GDPR, the right to an explanation for the output of automated decision systems for sensitive use cases like, do you deserve a loan, should you get a job, etc. But the trouble is that they didn't actually define an explanation. Right now we're in a status where basically the legal experts will say, someday this is going to go to court and a judge is going to say what part of a machine learning pipeline actually needs to be explained. And I kind of see the same with GDPR. So I think there's there's the way we think about explanation in the technical community, but that's not always what, if you ask a legal expert, you know, what an explainable system looks like or what needs to be explained, it's not always the features and the weights. So I think that's sort of the tension I see in the space, alongside the ambiguity of the definition of fairness and bias.
Yeah. Well, I mean, the reality is that it's a very fast-moving field. Things change almost weekly, if not even more frequently, right? So I think if you want to really set up an enterprise AI strategy, one thing you have to do to ensure sort of AI fairness is set up organizational AI governance and standards. And that has to be comprised of AI experts, business experts, AI ethicists, and data experts for sure, right? We talked about data a lot. And this governance body and the governance framework will really make sure that the data is being leveraged responsibly, data privacy laws are followed, and that's changing every year, as we see in terms of GDPR and other initiatives in Canada. I think even in the US, it's going to come down pretty hard. That's my projection. And also bias in AI systems. So the one thing to remember is that biased AI algorithms can actually potentially result in AI systems that make costly mistakes, that reduces customer satisfaction, and ultimately, actually, more importantly, damages a brand's reputation. And one has to be very careful on that front. So this needs to be addressed by governance and standards. And one way that we look at bias in AI models, AI models are built by human beings, and we use data that could be biased. So continuous back testing and validation of these models on new data with data experts to make sure that there's no inherent bias that's creeping in with terms of using old data or particular types of data without reflecting the full population is one thing. Now, on the flip side, though, I think that AI can actually help in responsible lending. There's a large portion of the worst population that does not have access to credit. And now you have a lot of humans and banks making decisions. AI can actually help speed up the credit decisioning process and help serve the underserved population by using non-traditional methodologies. So, obviously we need to make sure that AI systems are unbiased and responsible and transparent. But on the other hand, there's a lot of benefits of AI in banking because it can help the underprivileged, the underserved right now. And we have cases even in this low interest rate environment where folks are having to pay 15, 20% interest rate because they need the money for day-to-day activities. And the AI can really help there.
And just to jump in, I mean, I think that this is a very classic high-level argument here. And I think on the one hand, and the most important hand, I think right now, societally and functionally for enterprises adopting AI, we are at a kind of difficult point with modern models with explainability and even being able to certify any notion of fairness. And I'll note, Kathryn, just riffing off your point, I mean, explainability, I think I've seen survey papers, even reviewed some recently, that have just as many definitions of what explainability should mean in the community as definitions of what fairness should mean. And that's not an excuse to shirk the responsibility socially and otherwise, morally, et cetera, to do something, because I think we have enough consensus on the rough direction. But it is, I guess, to say that I'll put it this way, when academic communities and new academic communities spring up and get as excited as they do, and when us academics get too excited about something, you should worry about the the pragmatic state, right? Both around the theory and the even definition of explainability, fairness. But I do want to say, obviously, the high-level opportunity with any AI system, ML or not, is the ability to make systemic corrections when you have some bias. So if we can solve this challenge of detection, and I'll get to just some high-level notes on that in a second, then obviously, you can correct a bias more than you can correct the bias. You can write a couple lines of code and correct the bias you've identified in ways that you couldn't with, say, a bunch of analysts who are just using their gut instinct to make loan decisions based on what they feel like about some person who applies. And so that's always been the opportunity, and I think we still very much believe it. Identification is often the hard point there. And I just want to give a note there that I think there's so much motion even on the theoretical understanding of how to interpret what is a modern, especially a deep neural network, doing, that I think there has to be a mix of kind of theoretical and kind of core approaches to explainability and fairness and bias, but also just pragmatic techniques. So I want to riff off something that Prashant, you said earlier about just good experimental design, right? Setting up modular components that can be evaluated well is one answer to interpretability that is still going to be one of the cornerstones. Using simpler models when complex ones are not necessary, being able to audit how your data is labeled, that's something that we focus on. Basic pragmatic things are going to be the mainstay, I think, of responsible AI practices today until the academic fun kind of resolves on the core principles, which will happen, but not right away.
Yeah, Alex, just want to add to what you said, like bias is also many times domain specific. Like in a health domain, we want to differentiate between gender and race, and in a finance domain, we do not want to do it. So depending upon what kind of a solution we are building, we need to see what kind of a bias is genuine, what kind of a bias is not genuine. A second is, as Ashit mentioned, like there is an inherent bias in society also. So AI gives us opportunity to correct that bias. And then we want to ensure that we identify the bias in society, and we should ensure that do we want to present what society has today, or we want to correct it. And then the quick steps generally I've seen in Google and other companies were bias comes at a data collection process, it comes at data processing stage, it comes at algorithmic stage, and then it comes at a feedback stage because the feedback loop continue to get changed. And then as you said, like there are papers based upon that one can build solution which fix the population bias, behavior bias, or temporal bias. Like one of the technique we built at Google was TCAF. So using that, one can determine what model is actually learning. So yes, this is an area where AI will evolve, and I think we need to look for opportunities that how we can make AI more unbiased.
We are out of time, so we do have to end the session, but this has been an awesome discussion. And the great thing is that we can continue the conversation in the networking app in the during the event. So I want to say a special thank you to all of our panelists, and thank you to Kathryn for moderating. That was awesome, and we really appreciate your content. For the audience, go ahead and make your way to your next session, and along the way, make sure to accept your connection requests and check out our AI exhibits. Thanks so much, and we'll see you around.